As all my listeners know, I like to give them options. This is Newton's universal law of gravitation. You have one mass over here and another mass over here, and the force they exhibit with each other is the gravitational constant times the mass of 1 and 2 over the radius squared, and that's the force of gravitation. Now, this is where math is problematic. If you try to say this is universal, what you're doing is closing your mind. I'll show you a few things that are wrong with that. Newton's universal law of gravitation is not universal. General relativity does not solve for two bodies, or more than two bodies either. For instance, this universal law is a force between two bodies. Here's the first point. Solar system contains many bodies. Boom! Huge issue. Actually, we're going to find that the majority of star systems have more than two bodies. So right off the bat, the universal law of gravitation and general relativity both are incomplete, and they do not solve for actual orbital parameters. Nor do they actually explain gravitation, but more on that later. Their masses decrease as they evolve. This is in stellar metamorphosis. Obviously, stars cool, shrink, and die, solidifying and differentiating their interiors, becoming what's called a planet. This Newton's law of gravitation, it doesn't say that anywhere. So boom, strike two. Inside of gaseous stars that are forming cores, their idealized centers of mass are not actually centered. This is idealized for all systems. So you have the core in the center, and this is stable, okay? But sometimes when the orbit changes, you have an off-center focus. That's some stars, when they change orbits, they start to wobble. This is what Uranus and Neptune are doing. That's why their magnetic fields are crazy in reference to their actual axis of orientation. That was strike three. Strike four is the sun possesses the majority of the angular momentum, which means the Newton's universal law of gravitation, there's no way he could have accounted for this. He doesn't even mention this at all. Neither does Einstein, neither does Copernicus. They have the sun as being stationary, and then the other stars going around the sun, and the sun's just boring as sitting there. Of course it's not going to have any angular momentum. But the truth is that the sun is moving through the galaxy, dragging all the planets, or older stars, whichever you want to say, with it. Which means this also has the most mass and the most angular momentum. It's dragging these things along with it. Imagine a large earth mover with giant chains in the back of it, driving through a junkyard. And as it drives through the junkyard, it just grabs random cars and trucks and just drags it along with it as it goes through the junkyard. The sun's motion through the galaxy with other stars, they're being dragged along with it. That's how it actually happens. So where does it say that in this universal law? It doesn't say it anywhere. So what we need to do is keep in mind, the solar system contains many bodies, so that's strike one. Strike two is the masses decrease as they evolve, which means the gravitational fields shrink, which means they can't grab onto objects very easily. As well, smaller objects, they get adopted by larger objects as they move through the galaxy. So if there are smaller objects in front of this sun, okay, it's going to go straight through that area, and it's going to boom. It's going to start having these objects start orbiting it as well as it moves through the galaxy. That's how it adopts objects. It can't adopt objects like this because it's not moving. See how problematic that is? But that's how mathematicians think. They don't look at things creatively. They look at math equations, and that's not how science is done. And inside of gaseous stars that are forming cores, idealized centers of mass are off kilter. So basically, what this means is if we have an off-kilter magnetic field to an orientational axis, it means the star had been adopted recently. if it has a stable core and the magnetic field is almost in line with the axis of rotation axis, then it's stable. It's been there for a while. Anyways, that's about it. I can go ahead and do this again if you want me to, Baz, but that's just where my mind is going. Today is April 26, 2016.